Welcome to part 2 of the area underneath the curve and the distance problems. So to give a formal definition of our area, right, of the region S that lies under the graph of a continuous function f is the limit of the sum of the areas of approximating rectangles. And that depends on, if we're using the right or left endpoints. The right endpoints is the limit as n approaches infinity of f of x sub 1 times delta x plus f of x sub 2 times delta x, all the way down to f of x sub n times delta x. And the left endpoints is the limit as n approaches infinity of f of x sub 1 times delta x plus f of x sub 2 times delta x, all the way down to f of x sub n times delta x. And again, depends then on which one we're referring to, and these two limits should be equal to that same amount based upon those rectangles that we're finding. So with that being said, another approximation then to this, we could find the height of the ith rectangle to be the value of f at any number of x sub I star in the ith subinterval, with these x sub i's being sample points. And within that closed interval range of x sub I minus 1 to x sub I. So we could see that going down in this picture here, where we could find basically those sample points at any point within the rectangle to help us try to approximate that area a bit better, to limit the size of the over and under estimations. And as you can see, we can even take the limit as n approaches infinity of each of those calculations. So it gives this idea of these lower and upper sums. We could find the lower sums the minimum, or upper sums maximum for the value of f on the ith subinterval. So the lower sums, they have that missing space, and the upper sums have the extra space. Combining them tries to make some calculation that does a better approximation. So to help us write these approximations out, we have the sigma notation to write these a bit compactly. So the sum from I is equal to 1 to n of f of x sub I times delta x is f of x sub 1 times delta x plus f of x sub 2 times delta x, all the way down to f of x sub n times delta x. And we can express that area then as a is equal to the limit as n approaches infinity of the sum from x sub I, from I is equal to 1, up to n of f of x sub I times delta x. And we could take that based upon if we are using this, here's those right endpoints, this one's the left endpoints, and then these are these sample points that we were referencing. Well, all those areas should be the same. And the sigma notation is just used to help us to make the calculation look more compact. So to give an example, based on the graph I have here, we want to use 6 rectangles to find the estimates of each type for the area under the given graph of f, x-axis, and the lines x is equal to 0 and x is equal to 24. So you can kind of see it in the graph here. We first want to use the left endpoints L sub 6, right? So using the left endpoints, our graph for that is then going to have, we're basing this on 6 of these. We're going to have something that looks kind of like these rectangles, right? And you could kind of already see what's going to be going on with each of these. Unfortunately, it does require a little bit of an estimation, since some of these points are not on easy to see lines. But these are the left endpoint rectangles I just drew. onto the graph. So to actually answer that, this uses L sub 6. And that calculation is going to be 4 times f of 0, since each of these has a width of 4, plus 4 times f of 4, plus 4 times f of 8, plus 4 times f of 12, plus 4 times f of 16, plus 4 times f of 20. And that's one too many parentheses. So what does that mean? So based upon approximations of each of these rectangles, we have something that amounts to 4 times 18 about, plus 4 times 17 and a half, plus 4 times 16 and a half, plus 4 times 14 and a half, plus 4 times 12, plus 4 times 8. This approximation gives us an area roughly 346. And as you could tell by these rectangles, this is going to be an overestimate of our area. For the right endpoints, our sub 6, right, we can manipulate this drawing a bit to then be for the right endpoints. So the right endpoints, and I did not erase one extra line there. Right endpoints. So this is going to be going up to right here. So it's the first rectangle. The second one, so that's about there. Of course, I'm just guesstimating these height sizes. So drawing, it might be a little bit off, but the same idea though still applies. As you can see, this one, some of these rectangles are definitely not up to the full height. But for the right endpoints, this one is going to be 4 times f of 4 plus 4 times f of 8 plus 4 times f of 12 plus 4 times f of 16 plus 4 times f of 20 plus 4 times f of 24. Again, based on the guesstimates of each of these heights, this is about 4 times 17 and a half plus 4 times 16 and a half plus 4 times 14 and a half plus 4 times 12 plus 4 times 8 plus 4 times 2. And this one gives an estimate of 282. And as you can see, we have a bit of white space underneath here. So this is going to be an underestimate. This one's flipped because the graph is decreasing from left to right as opposed to increasing. We also want the midpoints, m sub 6. So that's going to be our special points for this particular example. So let's do m sub 6. So those will attempt to give us a bit of a better estimate, which would then help us to get a slightly better area calculation, which should be within the ranges of the two values we just found. Based upon the graph, though, since we are trying to use a midpoint, it'll be about here. Oh, well, I shouldn't draw it like that. Based on the number of 2, So something about that. And then we have here. So as you can see, it tries to mishmash the over and under estimates to obtain a, not perfect, but a decently, a decent area. So something along the lines of that, based upon these midpoints. So M sub 6. This is going to be 4 times f of 2 plus 4 times f of 6 plus 4 times f of 10 plus 4 times f of 14 plus 4 times f of 18 plus 4 times f of 22. Again, these are guesstimates based upon what the graph shows us. This would be about 4 times 17.8 plus 4 times 17 plus 4 times 15.8 plus 4 times 13 plus 4 times 10 plus 4 times 5.8. And this gives us a better estimate of about 317.6. So the best estimate of the true area is going to be based on the midpoints, as we have calculated. Let me know if you have any questions or concerns, and be on the lookout for part 3. Thank you.